Okay, before we proceed to the next situation in which we can apply the de Moivre theorems, okay, I would like to ask you one question. Do you know that if you have z to the square root of z, okay, other way to write square root of z is z to the power of y over 2. Do you know this? This is for square root 2. Okay. What if you have cube root of z? Do you know that you can write this in this form? Do you know this? And so on. Until you have n root of z, okay, you can write this into this form. Sorry, it is n. Do you know this? Okay, so this is basically what you need to know about transforming or writing the other form of mathematics. Okay, so for square root of 2, it is equivalent to z to the power of half. Cube root of z, that is equivalent to z to the power of 1 over 3. And it continue until if you have square n roots, okay, of z, that is equivalent to z to the power of 1 over n. Okay, so now the next situation where we can apply the de Moivre theorem is to finding the roots. Okay, finding the root of z. So we want to simplify things because we want to apply the de Moivre theorem to find, okay, the roots. So we write n roots in this form. Okay, so that it is easy for us to apply the de Moivre theorem. Okay, because now it is in the power in the form of z to the power of something. Okay, to the power of n. Okay, it's just that now our n, okay, before this you have for de Moivre theorem z to the power of n equal to r n, okay, cos n theta plus I sin n theta, right? Okay, now your n here change to 1 over n. So you will apply the same thing to the z. Okay, now n change to 1 over n. But the way you apply the de Moivre theorem does not change. So r, if this to the power of n, if your n change to 1 over n, it will also change to 1 over n. Okay, so cos, just now when your z is to the power of n, you multiply your theta with n, right? Now because your n has changed to 1 over n, so you multiply with 1 over n. Okay, plus I sin, sorry, I write it at the bottom here, okay? 1 over n multiply theta. Okay, so now to find the roots, okay, when you write in this form, it is in the fraction form, means it is finding the root. Okay, it is finding the roots. Alright, which is equivalent to this. This is the formula that we're going to use. Okay, once we apply the de Moivre theorem, now our z to the power of n will become this. Understood? Alright, okay, that is one thing. Okay, now because this is a finding roots, okay, and there is no it can be, it is not a unique solution, so you can have more solution, okay, many solution, okay, I mean many solution, and this depend on your argument z or your theta. We have learned in the previous slide, okay, I did mention that your argument, your theta, okay, is not unique. Okay, so in the Argand diagram, wait, I think I need to clean this first. Alright, what does it mean by argument z equal to theta plus 2 pi k? Okay, so I did mention that k is your rotation of your z on the Argand diagram, right? Okay, so let's see if this is your Argand diagram. Okay, and this is your z. Alright, if your k is equal to 0, means your z is just static here. Okay, but when your k is equal to 1, that means, okay, your k has moved and made one full rotation back to its original place. Okay, its original position. Okay, so it makes one circle, full circle, 360 degree. Okay, so that's why when your k is equal to 0, this is 0. Okay, so you will only have whatever your theta here is. So it's static, it does not move anywhere, it's just there. Okay, but when your k is 1, what happened? Okay, when your k here is 1, this will give you theta plus 2 pi. Okay, pi is equal to 180. If 2 pi means it is 360. So it moves. Okay, so your theta here is, whatever your theta here, it will plus another 360 degree. So that's why it moves. Okay, move, make a full circle back to here. Okay, 360 degree. Alright, and so on, it continues. Okay, if your theta, if your k equal to 3, okay, k equal to 2 lah. Okay, k equal to 2, what happen? If this is your z, and k now become 2, 2 times 2, 4, it become 4 pi. So 4 pi, you multiply with 180, you will get 720. 720 equivalent to 2 rotation. 2 rotation, full rotation of 360 degree. Okay, so this is you plus another 720. Okay, means here this Z will rotate one full circle, that is one rotation, and then it repeat again back to its position. Okay, so you see it makes 720 degree plus with this rotation, and so on until your k is equal to n. Okay. Okay, from the previous equation that are right, to finding the roots for z to the power of 1 over n is equivalent to 1 over n r to the power r over n, and your cos equivalent to 1 over n times your theta, right? Okay, plus I sine 1 over n times your theta, right? Okay, so in this case, your theta is for static theta, which is k equal to 0. Okay, now we want to modify this equation to become general. Okay, because we know that our theta is not unique. Okay, so we create formula or equation so that it will become general and can be applied for all k. Okay, so when we do that, okay, we just change our theta here. Okay, argument z, which is our theta here, 2 theta plus 2 pi k over n. So n here will remain to be n. It's just that the theta here we change to this because we want it to become general. So here when your k is 0 here, so everything will be 0. You just leave with theta over n, which is similar to this. Theta over n. Okay, sorry, but what if your k is 1? Okay, if we just use this formula, this cannot be applied for k that is greater than 0. So by transforming the equation to be general, now it can be used for all k. Okay, whatever k is. Okay, so when k is 1, it will become theta plus 2k. Okay, so this is where this equation came from. Okay, still using the Moivre theorem. Okay, it's just that we modify a little bit to become more general. Alright. Okay, you have two equations here. You can use theta in degree for this formula. Okay, for theta in radian, you use this formula. Okay, and k is from 0 up to n minus 1. Okay, so k will depend on your n. Okay, if your n is equal to 3, your k is 0, 1, 2. Okay, this. Nampak? You see? K must be from 0 up to n minus 1. So, if your n is equal to 3, your k will start from 0, 1, and n minus 1. 3 minus 1 is 2. So, stop here. So, means here, your roots, okay, ada 3. Okay, 1 for 0, 1 for 1, 1 for 2. Okay, so you will have 3 roots. If your n equal to 10, okay, your k, your root is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because 10 minus 1 is 9. So it's top here. You see here, you have 9 roots for that z. Okay, understood? Alright, before we proceed with this example, I have one thing to clarify, okay, to you, alright, about converting from degree to radian, okay, and from radian to degree. Okay, so let's see if your theta is equal to 45 degree. Okay, so you have your theta when you apply a tangent of b over a and you get your theta in degree. Okay, so this is in degree. And then you change your mind that, oh, I want to apply radian. Okay, so if you have that idea, okay, you can convert degree into radian. Okay, you can by applying this. We know that pi is equivalent to 180, right? So, if you have 45 degree, what is your pi? Okay, so you just cross product this. Okay, 45 times pi. Okay, 45 times pi. Okay, that going to be in that side. And in this side is equivalent to 180. Now we change our unknown here to x. Okay, so x. So now you can find your x is. So your x is 45 pi over 180 degree. So degree with degree here will vanish your unit. So there is no more degree unit here. What you have here is only your answer in pi. Okay, so this is equivalent to 1 over 4 pi. Now your answer now is in radian. So 45 degree is equivalent to pi over 4 radian. Okay, so if you want to change your radian 2 degree back, okay, same, you apply the same thing, where pi is equivalent to 180. Now you have pi over 4. Pi over 4 equal to how many degree? Let's say this is our x. Okay, we change this to x. So cross product this, you will have x pi equivalent to 180 pi over 4. So finding x means you bring your pi to here. Okay, so 180 pi over 4 times 1 over pi. So pi with pi we cancel, and 180 divided by 4, that will give you 45 degree. Okay, so now you don't have to confuse anymore when you, doctor, when we want to use the formula of finding roots, okay, for degree, and when we want to apply the for radian, it's up to you. Okay, if you find theta in degree, you use the first one. If you find theta in radian, you use the second formula. Okay, but still you can interchange. If you have the degree, theta in degree, you want to use the second formula, which is in radian, you just convert to here. Okay, and vice versa, right? So this is how you interchange or convert your unit from degree to pi, to radian, and radian to degree. Okay, I'm going to clean this. Okay, so I delete this, and we will concentrate on the example. Right, for this example, you need to find all complex roots of, all complex cube root of z equal to 1. Alright, so it is mentioned here cube roots. So means this. Okay, or z to the power 1 over 3. Okay, it mentioned here all means you need to find for all k. Okay, starting from 0 until how much? How many? Okay, that will depend on your n. Okay, so this is your n. Cube is 3. Okay, so you need to find for, if this is your z, alright, you need to find for z to the power of 1 over 3. Okay, so 1 to the power over 3. You need to find the cube root of this. Alright, so remember this is complex number, so it's just not simply 1 to the power of 1 over 3. Okay, alright, so you need to follow the procedures. You need to find the O for all k. Okay, alright, so now things that we need to determine first, alright, is n. Okay, so n here is depending on the roots. Okay, so n mentioned here is 3. So you need to determine this first, and then once you know what is your n, so you know where to stop your k. Okay, so k will start from 0 up to n minus 1. So n minus 1 is 2. So means here k is 0, 1, 2. Stop. So you have 3 roots here. Okay, then you need to find your r here. Okay, so you know your a is 1 and you have none for B. Okay, so you find your R. Okay, I don't want to repeat this many times. You can try this. You should get R equal to 1. Okay, and for theta, when you apply arctangent of B over A, okay, you get 0 degree. Okay, so 0 degree. Here, okay, we apply the second formula, which is in radian. Okay, because this for theta equal to 0 degree, it is spatial. Why is it spatial? Because it won't affect anything because you have 0. So 0 degree or 0 radian, it won't affect anything to here. Okay, but if this is something degree, like 10 degree or 40 degree, or 50 degree and so on. Okay, you have the degree, you must use degree. Unless you convert your degree to radian, then you can apply the second formula, which is for radian. Okay, do you understand that? Okay, because this is 0 degree, so it is just 0 here, nothing. Okay, so whatever unit you use here, whether it is in degree or in radian, it won't affect. Okay, because the only unit that is left, right, is this part only. Okay, because this is 0. Okay, 0 degree or 0 radian is means 0, mean nothing. Okay, but if this is something in degree, you cannot mix with radian. So you have degree here, but you use radian formula, you can't do that because they have different unit. This is degree, this is radian. So you cannot mix them up. Alright? So if you have degree, you must use degree 360K, if I'm not mistaken. Okay, for this. Unless you convert your degree to radian, then you can apply this formula. Okay, and vice versa. If you have radian, you must use radian formula unless you convert your radian to degree. Alright? Okay, so write your formula in general, substitute whatever the value that you have here. Okay, so you have 0, so 0 here, and then this is your general equation now. Okay, now the things that is left for you to do is substituting the value of k here. Okay, because you have substitute all the info that you have here, okay, into the general formula, right? Because you have n here, you have to substitute n here, you have substitute your theta here, which is 0, okay, and then you leave your k to be in general, okay, you substitute n here, now it become a very general formula, and just leave substitution of k into it. Alright, so next you just substitute. First you do for k equal to 0 first. Okay, so from the general formula that we have in the previous slide, now we substitute for k equal to 0. When k equal to 0, what we'll have is cos 0 plus I sine 0. Okay, so you can substitute this. Okay, find the value of this from calculator, you get 1. Okay, now because you have k from 0, 1 and 2, so you need to do for 1. Next is for 1. Okay, when you substitute k equal to 1, you have 2 pi over 3. Okay, same to this. So substitute into calculator, you have this. Alright, and the last one is for k equal to 2. Alright, so when you substitute this into your calculator, you should get this answer. Alright, so you have how many roots? You have 3. 1, 2, 3 roots. Okay, alright. So this is just additional information that you can give to your from the roots that you find. Okay, just now you have 3 roots, right? You can sketch them on the complex plane or on the eigen diagram. Okay, so this is the first root where your k is 0, and this is the second root where your k is 1, and this is the third root where k is 3. Okay, so all these n roots of unity, okay, they lies on the circle with radius 1. Okay, so the radius from the origin to your z is 1. This is also 1. This is also 1. So the radius is 1. Okay, so this is the locus of your z. Okay, where the original z is here and it rotates full circle. Okay, so this is the locus of the rotation. Alright. So if you were asked to sketch the roots on the complex plane or the eigen diagram, this is what you need to do. Okay. Okay, next example is this. Okay, let's say if you have z to the power of 4 plus 1 minus I equal to 0 and show the roots on the eigen diagram. So towards the end, after you find all the roots, you need to plot the eigen diagram. Okay, so you need to rewrite this equation, become z to the power of 4. Okay, bring the rest of this to the right hand side. Now you will have minus 1 plus I. Okay, so finding the root of this, okay, finding the roots of this, okay, is equivalent to this plus I to the power of 4, right? Because this is z1 over 4. Okay, alright, so now we concentrate on this. Alright, so we gather the information that we need first. Okay, what do we need? We need to know our n so that we know where when to start when to stop the k. Okay, so n here is 4. Okay, 4. So this means okay, our k is from 0, 1, 2, 4 minus 1 is 3. So that this is where we stop our k. Right, and we have a equal to minus 1 and b is equal to 1. Okay, so we need to know this information because we need to find r and we need to find the theta. Okay, that's it. That is the information that we need to gather. Right, so we move to the next slide. Okay, you continue finding the r and you will get r equal to square root of 2. Okay, and then you'll get your theta, okay, equal to 135 degree. Now it is in degree, so we'll choose the first equation, okay, the first formula to find the root. Okay, okay, we use the degree formula because we find theta in the degree. You can try this example later, but using theta equal to radian. Okay, try. You should get the similar answer. Okay, alright. So we substitute all the value that we have here into the formula, but leave the k because k we substitute later. Okay, we just get the general formula first. Okay, so we have this. Alright, 135. Okay, this is your theta, and this is 360 degree plus k. K leave there. This is your n. Okay, this is your r. Okay, this is the punca kuasa 4 tadi. Okay, 1 over n. Alright, so first, okay, refer to this. K is 0, 1, 2, 3. So do first for K equal to 0. Substitute the value of K in here. Okay. Once you substitute there, okay, you just perform the operation. This is 0, so you get 135. Okay, 135 divided by 4, so you have 33.75 degree, same to this one. Okay, solve this, you should get this. Okay, so that is your first root. Now proceed to K equal to 1. Okay, when you substitute in K equal to 1 into the equation that we have just now, K divided by 4. So now K is 1. Okay, 1. So 360 plus 135. Okay, you add them, divide by 4. You get this angle and this. Okay, so insert or substitute into the calculator. You should get this. Okay, and then proceed to do for the third root and the fourth root. Okay, so you have 4 roots here, including for K equal to 0. Alright, okay, we haven't finished yet because the question asks you to plot into the Argand diagram, right? So plot into the Argand diagram all the four roots that you find here, you plot on the Argand diagram. Okay, so the first root, K equal to 0. This is for second root, K equal to 0. K equal to 1. Okay, this is the third root for K equal to 2. And this is for K equal to 3. So from this Z, okay, remember R here, if it is square root of 2, this should be square root of 2 as well. Okay, and this is the locus of the rotation. So K is equal to 0 is static here, and then it makes one circle, one full circle. So it's 360 plus another theta. Okay, rotate on. Okay, this is sketch the Argand diagram. So I guess that's it for part 3 of complex number. Okay, so next thing that I want you to do is I want you to do this exercise as an assignment in the Google Classroom. Okay, I will make a proper assignment. Okay, type it in words or PDF form. So you download from there. Okay, and then you solve this solution and this exercise, and please submit through Google Classroom. Okay, so that is as a proof of attendance for our lecture part 3. Okay, where we cancel our online lecture for on Tuesday. Okay, so to allow you to register in the campus. All right. Okay, so thank you very much. I hope you will understand all my explanation, and if you don't hesitate to contact me. Thank you.